So here's a problem we did in class today. Someone wanted to see it done out again. So it says a car with a mass of 1,500 kilograms is being towed at a steady speed by a rope held at a 20-degree angle. Friction force of 320 newtons opposes the car's motion. What is the tension in the rope? So quickly, I'm just going to draw a simple little picture of my car with my rope. And we'll see that this is a 20-degree angle. All right, and if we look at it this way, first thing I want to do is I want to draw my free body diagram, because my free body diagram really drives what I'm going to do. So the first thing we've got is weight pulling it down. And because we have weight, we also have a normal force acting on it. And by looking at the rope, we can see that we've got a tension force going this way at 20 degrees, and it says we have some friction pulling it to the left. All right, so again, if we were taking the AP test, this would be a good free body diagram. But for our purposes, in terms of solving the problem, we need a little bit more. So to do that, I got to break my tension up into components where I've got T sub x and I have T sub y. All right, and we should hopefully notice when they say it's steady speed that T sub x should equal F sub friction, and the sum of the normal force and the y component of the tension need to equal the weight. All right, so we're looking for the tension in the rope. So I'm going to start by looking in the x direction, just because it seems like it's a little simpler. There's less going on in there that we have to think about. So I've got the sum of the forces in the x is equal to ma sub x. Now steady speed tells me that it's not accelerating, so this entire right half of the equation is equal to 0 because acceleration is 0. We call this dynamic equilibrium. Things are moving, but it's in equilibrium because there is no net force. So I start by writing what I've got, which is I know I have T sub x and I have the force of friction, and they're equal to 0. Now our force of friction is going to the left. We're going to call that negative, and our tension is going to the right, so we're going to leave that as positive. Now T sub x, if we draw a right triangle right here just to add it up, we see that it's the adjacent side. So that tells me that I want to use cosine for this, so we call it T cosine of 20 minus that 320 Newton friction force is going to be equal to 0. So then T cosine of 20 equals 320. And T is going to be equal to about 340 newtons. So that's it. Pretty quick, pretty easy. There you go.